All right, let's look at the homework 2.8, problem number 1. All right, let's look at this eigenvalue problem. All right, so we divided it into 3 cases. All right, so let's look at the case 1. Can lambda equal 0 be an eigenvalue? All right, so if lambda equal to 0, so the equation is y double prime is equal to 0. All right. Then we can take the antiderivative, so we know that the y prime is going to be some number, say a. Right? Take another antiderivative, you get the y is going to be antiderivative of a number is ax plus some constant, so I'm going to use b. All right, then we know that, let's see, y prime of 0 is equal to 0, so we take the derivative of y. Then we get, of course, derivative of ax plus b would be just a. And so if you plug in 0, so y prime of 0 is still going to be a. And we know that this is equal to 0. Right, so a is equal to 0. Right, so if you look at y of 1, right, so since a is already equal to 0, so it's going to be just b. Right, but that's equal to 0 again, so you know that the b is also equal to 0, so which tells you that so therefore y equal to 0 is the only solution. Right, so we know that this guy is not, so maybe I'll say not an eigenvalue. All right, so how about can eigenvalue be negative in this case? Right, so when it's negative, I'm going to, since it's a negative number, so for simplicity, I'm going to let lambda be negative some omega squared. Right? All right, so that way we can do a characteristic equation. So you have r squared. So lambda is negative, so it's a negative omega squared is equal to 0. Right? Then we can just simply factor it out. So you have r minus omega times maybe plus omega, and r minus omega is equal to 0, and which tells you that r is equal to plus or minus omega, right? All right, so the solution, general solution is going to look like y is equal to a e to the negative omega x plus b times e to the positive omega x. All right, so first we take the derivative. So I'm going to do a plug in 1. So if you plug in 1, so y of 1 is going to be, all right, so you have a times e to the negative omega plus b times e to the omega. Right? So this is equal to 0. Right? Then we take the derivative, so y prime is going to be equal to negative omega a e to the negative omega x, and derivative of that is positive omega b e to the omega x, right? Then we plug in 0, so y prime of 0 is equal to, right, so you have a negative omega a, right, e to the 0 is 1, so we just get that, plus omega b, right, and that's going to be 1 again, so this is equal to 0, right? So since omega is non-zero, it's actually a positive constant, so we can just divide it through. So we're going to actually get negative a, so I'm just dividing it through by omega, right? So we're going to plus b is equal to 0, right? And from here, we can simply multiply by e to the omega, so that this cancel out. So you're going to get A plus B times e to the 2 omega equals 0. All right, then we can simply add these two equations together. All right, so that's going to be 0. So you're going to get, so B is in common, and we're going to add e to the 2 omega plus 1, right? Because B times 1 is B. All right, this is equal to 0. All right, but we can see that e to the 2 omega plus 1, so this is never 0. So that forces B to be 0. So this implies that B is equal to 0, right? And if B is 0, because negative A plus B equal to 0, also A is 0 too. So A is 0 too. Right, therefore, again, we only get a trivial solution. Right, so again, this guy is not an eigenvalue. I'll just say not. All right, so we're left with the third case. All right, so let's look for the positive eigenvalue. All right, so since it's positive, I'm going to let lambda be omega squared. Right? So the characteristic equation would be r squared plus omega squared is equal to 0. Right? So this is going to be equal to, r is going to give you plus or minus omega I. Right? So we know that general solution is y is equal to a cosine of omega x plus b sine of omega x, right? All right, then let's plug in. Let's evaluate y of 1. All right, so you're going to get the a cosine of omega, right? Plus b sine of omega, right? And this is going to be equal to 0, right? Then we need to take the derivative. So we take the derivative. We get, it's going to be negative omega a sine of omega x plus omega b cosine of omega x, right? Then we plug in 0. So y prime of 0 would be, right, if you plug in 0, so sine of 0 is 0, so this goes away. So you're going to get omega b, right, cosine of 0, which is going to be 1. So this is going to be equal to 0. Right? So which tells you that, so divide through by omega, because it's a positive number. So b is equal to 0. All right, so going back, we know that here, so a cosine of omega x, but the b is 0, so we can actually scratch this term out. All right, so you have a y of, all right, so we're going to have a y, actually, we're going to scratch this out too, right? Look at this condition. So we want the a cosine of omega is equal to 0. Right, so since we're looking for a non-trivial solution, we have to make sure that the cosine of omega is going to be equal to 0. So we want this guy to be 0. Right, so in order to have cosine of omega equal to 0, I'm going to go down here. Right, we know that the angle has to be pi over 2 and plus any multiple of pi. So omega is equal to, right, pi over 2, so that the cosine will be 0. And then you can actually add any multiple of pi. So I'm going to put the n pi. Right, so this is where n is any integer. Right. All right, so let's look for the eigenvalue. So remember that eigenvalue is the squared of that, right? So this tells you that eigenvalue lambda is actually is equal to. All right, so we have to actually square this. Before that, maybe I should rewrite it a little bit. So omega is equal to, I'm going to write it as taking a common denominator, so it's 2. So n pi, so it's going to be a 2n plus 1 pi, right? So you just have to square this. So we know that this is going to be, right, denominator 2 squared is 4. And we have 2n plus 1 squared and pi squared, right? And this is for n being an integer, any integer, so n is an integer, right? And this is equivalent of saying this. So this is equivalent to, right? So this looks a little bit different. So you can actually leave it like that, or here I decided to write it this way. All right. So since when n becomes, so for example, -1 or -2, this quantity is going to be negative, but it's going to get squared anyway. So you're going to start getting the same value, right? So we can actually start from n equals 0. So this is actually the same thing as, we can just n equals 0, 1, and 2, and so on. Because we don't really need a -1, -2, -3, because it's going to produce some of the same numbers here, right? All right, then, so I didn't like this notation. So if I start from, if I want to start from 1, I actually start from 2n minus 1. That way we can start from 1. So I just rewrote it as n, lambda sub n is equal to, right? I'm going to reduce the indices by 1. So you have a n minus 1, 2n minus 1 squared over 4 pi. Right? So what happened is, since I reduced this indices by 1, I can start from 1 instead of 0. So that's why we can say n is starting from 1, which is a natural number. Right? So that's why I have this expression, but you can leave this expression as well, right? If n being an integer. All right. Then we want to find the eigenfunction. So eigenfunction in this case is going to be, right, so it looks like we have a cosine here. So eigenfunction, you can use y sub n or f sub n, either way. So in this case, I'm using y sub n. So y sub n is equal to, right, so it's going to be a cosine function. So you have a cosine, right? And then you have omega x. So omega, we found that to be this guy, right? So you have a 2, actually I'm going to reduce it. So you're going to have a 2n minus 1 over 2 pi. Then you have an x, right? And of course, n is any natural number, right? So that's how we get the eigenvalues. So these are multiple values here. And also this is the eigenfunction. All right, that's it. I hope that this was clear.